Hi guys, in this video we will solve Leetcode problem number 3919. In this problem we are given array nums where nums is strictly increasing. This is one point you have to notice. Array is strictly increasing. From any index x you can move to index y with the cost is equal to nums of x minus nums of y, absolute of nums of x minus nums of y. Or if y is the closest of x, if y index is the closest of the x, then you have to pay only one cost, and the index is closest when the absolute of nums of x minus nums of y is minimized. So that means if this is the x index and it have two index adjacent element x plus 1 and x minus 1, if x plus 1, like difference of nums of x plus 1 minus nums of x is minimum, so that means we have two cost. One is if that is the closest, that index is the closest of x, then you have to pay only one, and if it is not closest of, then you have to pay the difference of these two element. Suppose if you want to go from x to y, like x index to y, then you have to pay the difference of these two indices. Difference of, if element at yth index contains the value 5 and xth element contains 2, then you have to pay 5 minus 2, which is 3. And if y index is the adjacent element of x and giving the minimum value, then you have to pay only one cost. And also it is given that the array is strictly increasing, means always the difference of any two indices must be greater than or equal to 1, because it is strictly increasing. So that means if we have two options or two ways, first is the nums of y minus nums of x and other one is only one cost, then what will be the best way? It is always the second option is the best, because any two indices have always difference greater than 1. So that means it is better to use the second option if possible. So that means, and also like if you have a query of L to R, you want to find what is the, like for we are given a 2D integer array queries where each queries contains Li and Ri. For each query we have to calculate the minimum total cost from index Li to Ri. One simple way is use of first operation. If you are using the first operation, then the cost will be nums of R minus nums of I and nums of L, because from index L you can move to index R by paying the cost of nums of R minus nums of L. But if it is possible, like suppose if you move from, suppose this is the Rth index and this is the Lth index, and you want to move from L to R, then maybe there is some index which is the closest of either L, then that for that index you have to pay only one cost. But maybe suppose this is L plus 1th index, maybe L plus 1th minus Lth index contains the difference of greater than 1. So it is better to use the second operation if possible. So we have to count how many indices we can use the second operation, and if we use second operation, how much how much cost it will reduce. So suppose previously the cost from movement from Lth index to L plus 1th is the difference of these two indices, that is nums of L plus 1 minus nums of L. But if you are using the second operation, then it will take only one cost. So that means how much you are reducing the cost. The total cost will be nums of R minus nums of L, because this is the maximum possible cost. So if we are using the second operation for this index, then our cost will reduce by, because we are paying only one for this index, and initially we are added this much value. So that means we have to subtract 1 minus the cost of, which is like the previous cost, which is n some nums of l plus 1 minus nums of l. To effectively find how much cost we can reduce, for that we have to pre-compute our reduction cost. That means if we are moving from left to right, and we know we have a suffix array that will store how much cost we can reduce from I to end. Our suffix array will store how much cost we can reduce from I to end. So when we can reduce the cost? Only when the right difference, like right side difference, is less than the left side difference. If left side difference will be less than the right side difference, then we can reduce, the cost. So that means our left will be greater than the right. That means for that index the right will be the closest of x. So that means suppose we have x and this is x plus 1th index, then if this is the right difference and this is left difference, then if left difference is greater than right difference, that means for x element the closest is x plus 1th. So that means for that we can reduce the cost by the total cost which we added previously, that is nums of x plus 1th minus nums of x. Now we are paying only 1. So that means how much cost we are reducing, that is 1 minus the total cost which we previously paid. Suppose you paid previously 10, now you have to pay only 1 cost. So that means how much cost you are reducing, that is 1 minus 10, which is minus 9. So that means we have to subtract from 10 this much value, which is 9. So now our cost is only 1. So that means this much value we are reducing. So to find how much value we are reducing, we are just using a suffix array which will calculate. Suffix of I will give the cost which we can reduce from I to end index. And similarly we have a prefix that will store, this is for the right side movement. Suppose we have a 0 to 2 movement, and maybe we have a array movement of 2 to 0. For that we have to move in from right to left. For that we have a prefix array, and prefix of I will store total saving from start to ith index. So this will store how much total saving we can do from start to ith index. And when we can, like, if this is x index and this is x plus 1th index and this is x minus 1th index, so when can be this, like our moment is from right to left, the condition when x minus 1th, the difference of this and this index will less than the difference of right side. So if this is diff 1 and this is diff 2, then if diff 1 is less than or equal to diff 2, then we can, with the help of only one cost, we can move from x to x minus 1, because x minus 1th is the closest of x. So for this we have to use, like we can reduce this much cost, which is nums of x minus 1 minus nums of I, the previous cost, 1 minus the previous cost which you paid. So that means prefix will store how much saving we can do from start to ith index. So if we know these two, like prefix and suffix array, then from that we can calculate what is the answer for any query. Suppose you have a query L to R, our query is L to R. Then for that we have to check if L is less than R, that means our movement is from left to right, and if our movement is left to right, then we will use the suffix array, because our suffix array store the total saving. So that means our answer will be answer previous answer, which is nums of, like the maximum answer, which is nums of R minus nums of L. This is the maximum value. In this operation we are using the first operation only. So with the help of first operation we can move nums of R, like from L to R, with the cost of nums of R minus nums of L. But we can use, for some indices we can use second operation. Now we have to subtract from answer the cost which we can reduce, that is the total cost, which is nums of L minus nums of suffix of L minus suffix of R, right? Because if we know from here to here, like suffix will store the total cost reduction from L index to end, and suffix of R will store the total cost reduction from R to end. So then if you want to calculate how much cost we can reduce from L to R, that will be the difference of these two, because suffix of L will store how much cost you can reduce from here to here, from L to end. And same way suffix of R will store the cost for R to end. So if you want to find the cost which we can reduce from L to R, that will be the difference of these two, because this is the area which is only red, orange. So that means if our moment is L to R, then we can use, like we will find how much cost for the first operation, that will be the nums of R minus nums of L. Then we will check how much cost we can reduce, like, and how many indices we can use second operation. If we are using second operation, then how much cost we can reduce. So the cost which we can reduce is the sum of L minus suffix of L minus suffix of R. So now if L is greater than or equal to R, then we will move from, like, this is for movement of L to R. Now if R is greater than L, then we have to move from right to left. For that we have to use our prefix array, because our prefix array store the cost for start to lth index. So we have to subtract prefix of, same way we have to subtract from prefix of L to prefix of R. So that means for each query we can find our answer with the help of prefix and suffix array. So now let's move to the code part. Let's move to the code part. So in the code part we have a suffix array which store how much cost we can reduce from I to end. So we'll start from n minus 2th index, because we have not, for n minus 1th index we have not any right index. So that means for n minus 1th index we can use only the first operations. So that's why we are starting from n minus 2th index. And for each indices the right difference will be the absolute of nums of I plus 1 minus nums of I. In same way the left will be nums of I minus 1 minus nums of I. If right difference is less than left difference, which means the right difference is greater for x, Suppose this is the ith indices, this is I minus 1th, and this is I plus 1th. So that means the right difference, this is the right difference is less than compared with left side. Then for these indices we can reduce our cost by 1 minus the cost of right side. Like this is the cost which we previously added, so now we can reduce 1 minus this much cost. So that's we are doing sum plus is equal to 1 minus right side. So we will assign the suffix of I is equal to sum. Sum is sum store the how much cost from ith index into ith indexes. And also for I is equal to 0, the suffix of I will be the sum plus the current operation, because for 0th indices we always use the second operation, which is the closest of x, because for 0 we have only one movement, which is 0 to 1. So that means that will always the minimum value. So for that we can use the second operation. So if you are using second operation, then cost will be 1 minus the nums of I plus 1 minus nums of I. Same way we will find the answer for prefix. Our prefix will store how much cost from start to ith indices. This will store how much cost we can reduce from start to 0 ith indices. So same way for n minus 1th indices, we can move only to the right direction. So that means for that we have to pay only, like we can reduce the cost by 1 minus nums of I minus nums of I minus 1. So same way, if right difference is greater than or equal to left, here greater than or equal to, like here equal to sign also, because in the question they are given that for if both have same value, then you have to choose the smaller indices. That means if I minus, for ith indices, if I plus 1th and I minus 1th both have the same difference with I, then you have to choose I minus 1th. So that's why we are using greater than or equal to. So our sum will be sum plus is equal to 1 minus the left difference. So now we are moving, for each query we have a L and R. We will check if L is less than or equal to R, then our answer will be the absolute of nums of L minus nums of R. This is the maximum value. This is the maximum value from which we can move from L to R. So now we can use some second operation. So if you are using on some indices second operation, then your cost will reduce by suffix of L minus suffix of R, because suffix of L will store from L to int and suffix of R will store from R to int. Then you have this much, you want to find the cost we can reduce from L to R, that will be the difference of these two. So we will reduce our answer by answer of I minus is equal to absolute of this much value, and we have to return the all the, like for each query we have to return what is the cost of movement, then we are storing that in our array. And same way we will find if our movement is from, like if R is greater, like here R is greater than, but if you have a query from 2 to 0, that means you are moving from right to left. In that case you have to use prefix array. So our answer will be answer minus is equal to absolute of prefix of L minus prefix of R. Then we will push our answer to the result vector. So at the end we will return the result array. Thanks for watching this video.